Okay, so let's see these step functions applied in real life. We've got some students that are planning a field trip. Good for them, all right. If there are 40 students and adults or fewer, so I'm just going to 40 students and adults or fewer, going on the field trip, they rent vans that hold 15 people. So they could figure out how many vans they need if they are bringing 40 people or fewer. If there are more than 40 students and adults, then they have to rent a bus, and the buses will hold 65 people. What function can you use to represent the situation? Well, because there are two separate pieces of this, we've got one thing, we'll get vans, and we have to figure out how many vans to get if we have 40 or less people. But if we have more than 40 people on the trip, then we're talking buses. So we're gonna write a function to represent how many vans we would need, and then another function to represent how many buses we would need. So let's define a variable. We're going to use x in this function, so we'll let x represent the number of people going on the field trip. FT for field trip. Okay, so if we have 40 students and adults or fewer, so we're going to say if x is less than or equal to 40, that means we're taking vans, right? So how many vans do we need? Each van holds 15 people. So if we take the total number of people that we have, you know, we could have 35 people. We will divide that by 15 because 15 people will fit in one van. That will help us determine how many vans we need. So let's just think about that for a second. If we have 35 people, and we take our 35 people and we divide it by 15, we get 2.33, it's 2.3 repeating, I'm just gonna say 2.33. So we go and we say, I just need 2.33 vans. And they say, yeah, you can buy 2 vans or you can buy 3 vans. You can't buy a portion of a van. So we need to round up. We would say, oh, yep, let's round that up. Ceiling function, we need 3 vans. So if it does not divide evenly, we just want to make sure that we have space for all the people. So we're going to get more van seats than we might need. So we're going to round up to the nearest integer because vans come in integers. All right. So there's our function for if we have 40 or less people. Well, what if we have more than 40 people? If we have more than 40, then we get to take a bus. So let's look at what this function looks like for the buses. Again, however many people it is, let's say you have 80 people, your number of people, if you divide it by the 65 seats on one bus, how many buses do you need? So for example, we said, what did we say, 80 people? We've got 80 people signed up for the field trip. So that number is more than 40, so we're taking a bus. So we take our total number of people, divide by the 65 seats on a bus, and we get 1.23. Well, again, we can't take 1.23 buses. If we round it down to 1, then we've got people that can't come on the trip. If we round it up to 2 buses, then we can accommodate everyone that wants to attend. So we're going to apply a ceiling function to this so that everyone can come on the trip. All right, so we have figured out the functions for if we're taking a van, if we're taking a bus. So let's put it all together into one function to represent the situation. We're going to take the function, this is the function part right here. It's the ceiling function of x divided by 15, but we only use that function when our number of people x's are less than or equal to 40. And I guess, why don't we be more specific? You can't have negative people, so we'll say 0 is less than or equal to x is less than or equal to 40. All right, well then we need to represent what if you have more than 40, so we're going to include the other part, the x divided by 65, apply the ceiling function to that, so we're rounding up, and we use that function when our number of people is greater than 40. And this is our function that represents the situation.